In this video, let's take a look at limits at infinity. So with limits at infinity, we have to look at what is getting bigger, right? So when we have a limit as it approaches, we'll say infinity, right? We have to look at if the numerator or denominator is getting bigger. So depending on which side of the fraction is getting bigger will dictate what is happening at x approaching infinity. But with limits approaching positive or negative infinity, and if the numerator is bigger than the denominator, then it will produce either positive or negative infinity as you approach infinity. While if your limit as x approaches positive or negative infinity, if the denominator is bigger than the numerator, then it will just be 0. However, if your limit as x approaches positive or negative infinity, if your numerator is equally getting bigger as your denominator, then you will take the ratio of the numerator and denominator, and this will give you your answer. Additionally, it's important to note that limits at infinity, you don't necessarily have to prove their left and right limit are equal to each other. So if we have a limit as x approaches infinity, f of x equals a, right? We don't necessarily have to prove that x as approaches negative infinity of that same function also equals a. Because when you get into limits at infinity, you often won't see this occur. In addition, another thing that you must keep note of is absolute values. For example, if you have a function and you have x over x in absolute values, or the other way around, 1 over x in absolute values, or another occurrence that you can get is root of x, because this will produce absolute values. Which we know that when we have absolute values, the graph will look something like this. And we know that when we have a graph like this, x at infinity will always be the value here. So it's not necessarily equals 0 or infinity, but it is the value that its y is. Okay, let's take a look at an example. So we have limit as x approaches infinity of 1 over x. So the way I like to think of this is, imagine you have one of something. It can be of anything. And if you have an infinite amount of people, for this sake, let's say we have a $100 bill. Let's say we have 100 people and we have that $100 bill. This means that each person is going to get $1. But as we increment 100 into infinity, that $1 bill per person will exponentially get smaller and smaller and smaller, to the point where the currency is practically worthless. There's no value and just 0. So as the denominator gets bigger than the numerator, we see that the value will be equal to 0. And that's the case whenever we have a higher degree or bottom heavy, or it's increasing faster on the denominator, it will always equal 0. The same case will be applied if we have the limit as x approaches infinity of x squared or x cubed or x to the power of 23. This will always equal 0 because the power is greater in the denominator than it is in the numerator, and therefore it is increasing faster on the denominator. All right, let's take a look at limit of x at infinity for 3x to the fourth power. So the way I like to do this or approach this would be just to plug in infinity into this equation. So what happens when we have 3 times infinity raised to the power of 4? When you raise infinity to the power of 4, it's still infinity. It continues to get bigger. And when you multiply it by 3, it only gets even bigger. So therefore, this is infinity. Or another way of thinking of this is look at the degree. Here the degree is 4, and the degree here can be seen as 1 or 0. And we know that either if we view it as 0 or 1, the numerator degree is greater and will always be greater than the denominator. And therefore it is top heavy. And because it's top heavy, we know that it will either be positive or negative infinity. But in this case, we know that it is infinity. Now let's say if we did negative infinity into 3x to the power of 4. I would still approach this in the same way by just plugging in negative infinity into the fourth power. And we know that any negative raised to an even power will always just be a positive. Like if we have negative 1 squared, this is just negative 1 times negative 1, which negative times a negative is always a positive. So we have plus 1. The same case applies to 4. So we have any value within the negative times another negative value will always produce a positive. So we have 3 times positive infinity, will just produce an even bigger number. Let's look at this example. So we have limit of as x approaches infinity of negative 2 times x to the fifth power. So if we plug in infinity into x, we have negative 2 times 8 raised to the fifth power, which we know infinity raised to any power will just mean that it continues to get bigger. And we have negative 2 times infinity. And we know any value that you can think of times negative 2 will regardless always produce a negative number because the infinite value will be positive. So negative times a positive is a negative, and it will just continue getting bigger. So this is negative infinity. And still, although this is a negative, we still see that the numerator has a greater power than the denominator, and therefore it is top heavy, and therefore it's infinity. Now let's look if we're approaching negative infinity. So as we see, negative 2 times negative infinity raised to the fifth power. So because we're raising this to an odd power, this will continue to be a negative. So we see negative infinity. However, we have a negative times a negative. And we know anytime we multiply two negatives, we will produce a positive value. So we get positive infinity. That's the answer. First, it may seem a bit informally formatted. However, we could format this as negative 2 times x sixth, right? And we can quickly see that this is top heavy. And because it's top heavy, we know it's going to be positive or negative infinity. So if we plug in, oh, I forgot infinity right there. So if we plug in infinity into x, right, we can disregard this because we don't need to look at that anymore because we know it's going to be positive or negative infinity. So, and we have negative 2 infinity to the 6th power. This is just going to be negative 2 times infinity. And we know negative times a positive will just produce a negative infinity. Okay, so in this example, we have x plus x squared minus 6 over 6x plus 5x squared plus 2x cubed. So from just looking at this, we can quickly see that the denominator has the highest leading power. And therefore, it is bottom heavy. And because it's bottom heavy, it will equal 0. By just quickly looking at this and seeing the leading exponents, we can tell if it's going to be positive or negative infinity, or if it's going to be 0, or if it's going to be the ratio between the numerator and denominator. However, if you don't know the leading power, we can take the greatest degree in the denominator and divide that to everything. So we see x cubed here. So we're going to divide everything because this is the bottom leading degree. So we have x over x cubed plus x squared over x cubed minus 6 over x cubed all over 6x over x cubed plus 5x squared over x cubed plus 2x cubed over x cubed. Oops, x cubed. Let me make a bit of room for myself. Okay. So, in this example, right, we know that this, and we're still approaching infinity. So, also from just looking at this, we can see the leading degrees for the top part, because this top part is at the bottom part. So, this is all going to be 0, right? Because we know that this is just going to be x over a greater infinite value. For example, if we plug in 2, this would be 2 over 8, which the denominator is greater, and therefore it will always be greater. And if we go back to that example where we have $100 bill and split it amongst 100 people, and then eventually 1,000, and then 10,000, and exponentially get bigger, that currency eventually becomes worthless and becomes 0. And we see that here too, and here too. So it's 0, right? And then if we look at this, just these two parts, we see that this leading degree is at the denominator. Same here. So this is 0 plus 0. And we see that x cubed over x cubed will just cancel, plus 2 over 2. Which we know this will just be 0 because anything divided by 0 is just 0. Therefore, this is one way to show your work, but a quicker and faster way is just quickly glancing at the degrees and then realizing which value is increasing the fastest and going based on that and coming to a conclusion. Okay, in this example, if you look at the degrees, we can see that the degrees are equal, right? We have 5x minus 3 over x. So we can see that this is a degree of 1 and a degree of 1. So therefore they're equal. And we're going to have to find the ratio between them. So we can just forget about this stuff. and just look at the 5 and 1. So we know 5x over 1x. This will cancel with this, leaving us with 5. And that's our answer. By realizing that the leading degrees, are equal, we just take the ratio between the leading degrees, and that gives us our answer. Here we have an uneven degrees. So we don't have a common denominator, and we're adding and subtracting. So a quick way to do this would just be to multiply each number so we have a common denominator, and we can add and subtract. So we see that our greatest degree is x cubed. So we want our denominator to be x cubed. So we're going to multiply 3 by x cubed, 3x cubed. However, this changes the original value. So to avoid that, we're just going to divide by x cubed. So this is still 3 plus 5x cubed. This is the same, and we're trying to get the same denominator of x cubed. Now here we have 6x. To get that to cube, we're going to multiply that by 6 squared. So we have 7x squared over 6x cubed. Now we can see that if we were to take these out, we would still get back to the same original value. So this is still equal to this. This doesn't change anything. Just makes us have a common denominator so we can combine like terms. So in this, so here we have 3x cubed plus 5 minus 7x squared all over x cubed. And when you look at that, we have equal degrees. So because we have equal degrees, we can forget about this stuff. We don't need to worry about that. We just need to look at the leading degrees. And therefore, we're going to find the ratio between the leading degrees, which is just 3x cubed over x cubed, which this cancels, and therefore we have 3. So we go back to our original equation, we have equals x. And that's our answer. So the main takeaways from the video is that when the numerator is top heavy, when it's increasing faster, we know it will produce a positive or negative infinity value. However, when the denominator is bigger or is increasing faster, we know that it will produce 0. And lastly, when both the leading coefficient or the leading exponents or the leading degrees are equal or are the same, we're going to have to find the ratio between the leading degrees. Or in other words, the ratio or the we're going to have to divide the leading coefficients of the highest degrees. And that will give us our answer as x approaches infinity.